and welcome back to another episode of Maths. In the last couple of videos, we introduced the idea of fraction multiplication, and we are going to kind of continue on this multiplication train and learn a couple of interesting applications and things that you can do with fraction multiplication. So the first one of these things that we're going to look at is going to be a cool little mental math trick. I'm sure you guys absolutely gobbled up that last mental math trick video we did, so hey, here's another one. And in today's video, we're not doing one, but we're doing two different mental math tricks. The first one isn't going to actually use fraction multiplication. It's going to be just something that relies on fraction addition, but I figured it was something that would be good to cover so that we can also use it in the second mental math trick today, which will rely on fraction multiplication. So without further ado, let's get into it. Alright, so the first trick is kind of like a take it or leave it sort of trick. In my opinion, it can often streamline your process of converting fractions into decimals, but it isn't necessarily faster than just kind of using your traditional division method. But here's the trick. So the form of the fraction where we can use this trick is where you have an odd numerator over a denominator of 2. Okay, so for example, if I gave you 51 over 2, I know immediately that that is 25.5. So I was using my mental math trick to figure that out. Or if I gave you 37 over 2, I know immediately that that is 18.5. So how am I doing this? Well, essentially what I'm doing is I'm noting that, okay, 51 over 2. 51 is the same thing as 50 over 2 plus 1 over 2, right? We know this because they have a common denominator, so we just add the numerators and we get back to 51, right? So 50 over 2, that's just an even number divided by 2, and finding a number divided by 2 is usually a pretty quick mental math process, especially when you have a lot of experience. So the more you do these, the faster you're going to get at them. But 50 divided by 2, I can just immediately mentally say that's 25. And then the 1 over 2, well, a half, that's another very common fraction, right? A lot of us know that that is 0.5. So this 25 plus the 0.5 becomes the 20.5 that I did in my head. So similarly, with 37 over 2, I went down by 1 to get to the nearest even number that's a little lower than it. So we have 36 over 2. But to make this equal, we need to add 1 over 2, right? So 36 over 2 plus 1 over 2, that is 37 over 2. 36 over 2 is 18. 1 over 2 is 0.5, so we get 18.5. So this is my method of doing this. Basically, you take the odd number, you lower it to be the next even number below it, and then it's pretty easy usually to divide the even number by 2, and then you just add in that 0.5. So this is the reasoning why it works. Of course, you don't have to do this every time. Kind of the idea with the trick is to just do as I said. So let's try another one. Let's try 161 over 2. Okay, so in my mind, I'm going 161. Well, 160, that's the next even number below it. So 160 divided by 2 is 80. And then I'm just adding my 0.5 from the one that comes after it. Let's try another one. Let's go 201 over 2. Okay, I know 200 over 2 is 100, and then plus that extra 0.5 that comes from the 1, we get 100.5, right? So this is kind of a quick little trick that in many cases I think can make it easier to convert fractions where you have an odd numerator divided by 2 into a decimal. It's just a little bit quicker. With that out of the way, let's get to the second trick, which is what I want to focus a little more on in this video. This one I can't just as easily write as like an odd numerator over 2 or something like that, but I'll just demonstrate a few of them and you'll kind of get an idea for what this trick maybe is. So let's say I have something like 4 over 50. I know right away that that is 0.08. Okay. I have 3 over 200. I know right away that that is 0.015. Oh man, how am I doing this? I don't actually have these written off to the side, I promise. In terms of, like, I don't actually have their answers. So 1 over 3,000. Okay, well, that is going to be 0.0003 repeating. Okay, so how am I figuring these out so quickly? So let me show you what I'm doing here. So 4 over 50, let's break this down. So 4 over 50, that's the same as 4 over 5 times 10, right? Because 5 times 10 is 50, so that's nothing different. But then what I can do is I can actually split this up into two fractions. So 4 over 5 times 1 over 10. Right, we see that 4 times 1 is 4, and 5 times 10 is the 5 times 10, or the 50, right? So I've basically kind of undone some fraction multiplication here to get two different fractions that multiply to 4 over 50. You might even say I've factored it if you want to kind of use that terminology. But now what I can do here is I can do 4/5. This is a fraction that I know how to convert mentally. 4/5 is 0.8. And then we're multiplying it by 1/10. But 0.8 times a tenth, I know if I have a number here where it's not written as a fraction, I can just do that number times the 1 in the numerator and divide it by 10. That's because 0.8 is secretly 0.8 divided by 1, right? So this gives me 0.8 over 10. But I know when I divide by 10, I can just slide the decimal over by 1, and I get 0.08. So this is the overall process that I used to convert this, but let's look at what actually happened. What basically happened is I was able to basically split out this 0 from the 50 in the denominator by pulling out this 1 over 10, right? So essentially what I did is I noticed, okay, 4/5, I can do that. That's an easy fraction that I can convert into a decimal. I know that's 0.8. And then this extra 0 here, what that ends up actually becoming is just this dividing by 10 part, right? So if we do 4 over 5, which is 0.8, and then that 0 is just telling me to divide by 10, which this is the reasoning for it, then all I'm doing is I'm shifting the decimal over by 1. And so that is the overall trick here. If you have something where your denominator is a multiple of 10 or 100 or 1,000 and so on, then what you can do is if you just ignore the zeros in there and you just look at the part without the zeros, and if that's a fraction that you can do in your head, then you can use this trick. So in this example, so I'll write this down here, 3 over 200. I notice, okay, 3 over 2. 3 over 2, that's 1.5. But then these two extra zeros, what that becomes is over 100, right? That, because this is really 2 times 100 in the denominator, right? So just following this process again, we really get this 3 over 2 becomes the 1.5. And then the dividing by 100 shifts the decimal to the left by 2. So we get 0.015. And then what I did for this 1 over 3,000 again, so I noted, okay, 1/3, that is 0.3 repeating. And then I took these 3 extra zeros, which is equivalent to dividing by 1,000, and I moved the decimal over and according 3 places to the left, which then became this decimal right here. So that's all it is to this trick. So let me give you an example. Let's say I did something like 17 over 50. Okay, so 17 over 5, if you've seen the other mental math trick video, we know that that is something we can very quickly do in our heads. 17 over 5 is 3.4. And then with this extra 0, we're just going to shift the decimal over by 1 because this is really just dividing by 10, and we get 0.34. So we can mentally say 17 over 50 is 0.34. Okay, let's try and be a little quicker. So let's try maybe 101 over 2,000. So this should be 0.0505. Okay, so how did I get that? Well, 101 divided by 2, right? So we're just ignoring all the zeros in the denominator. 101 divided by 2, that is 50.5, right? So this is actually me using the other trick that we learned earlier in the video. And then these 3 zeros is moving the decimal over 3 times. 1, 2, 3. So we get an extra slot here to put a 0, and that's how we get the 0.0505. So this trick is kind of cool because if you know other mental math tricks for converting fractions into decimals, then if you notice that that occurs without the zeros, so for example, a dividing by 5 or a dividing by 2, then you can do that trick. Then however many zeros you have, that's just the amount of times you slide the decimal over by. So this right here is your condition when you can use this trick. If your denominator is a multiple of 10, 100, 1,000, etc., so 50 is a multiple of 10, 200 is a multiple of 100, 3,000 is a multiple of 1,000, and if the fraction without the zeros in the denominator, so the 4/5 in this case, right, we're just ignoring the 0, the 3/2 in this case, we're just ignoring the 2 zeros, the 1/3 in this case, we're ignoring those 3 zeros. If that's something you can convert in your head, so 4/5 was a fraction we could convert in our head to 0.8, 3/2 was a fraction we could convert in our head to 1.5, a third was a fraction we could convert in our head to 0.3 repeating, then if you know that, then you can actually do this trick because you just convert it into the normal fraction and then slide the decimal according to the amount of zeros there. So, like all kind of mental math tricks, they're not always going to be useful, right? Oftentimes we're going to get a fraction where it's not of this form, where it's not something out of 2, where it's an odd numerator, or it's not an instance like this, where this is a pretty specific setup, right? Where we have a denominator that's a multiple of 10, 100, or 1,000, and then furthermore, when we cover up those zeros, we actually get something we already know, right? So that's a very specific scenario. But the whole point in knowing these tricks is that when you're doing math, these things do come up eventually. And if you're equipped with these tricks, it just makes your life all the easier. And even if you don't end up using this trick for a while, I think it's still useful that you learned this video because it allowed you to basically get more experience with using fraction multiplication. It allowed you to get more experience with this idea of kind of manipulating numbers and exploiting their properties in order to actually do things, right? In this case, figure out some sort of trick. And I think that's one of the really cool things of math is the more you learn, the more you can kind of learn to manipulate things and exploit things to make numbers and different processes actually do things according to what you want them to do, right? So I hope you found this video interesting. I hope you're feeling a little quicker with some of your conversions. And yeah, but until the next video, you have a good one, you stay groovy, and I'll see you then.
Please help!